We are beginning a new topic today, correlation and regression. Here are the objectives that we look forward to achieving at the end of the lesson. At the end of the lesson, you should know the difference between correlation and regression. You should be able to find the coefficient of correlation for a given data. You should be able to draw a scatter diagram for a given data. And you should be able to draw the line of best fit for a given data. Now let's learn more about correlation and regression. To do that, let's consider this scenario. A teacher measures the following data about students in his class. So a teacher goes to his class and he measures the following data. The first one is their ages and height. So let's assume that the teacher has 20 students in his class. So he goes to the class and he speaks to the students one after the other. He calls on the first student, they mention their age and their height. He does the same for the second student, the third student, and so on, up until the last student. He measures their ages and their height. Then, in the second scenario, he measures their score in a mathematics test and their number of days of absence from school. So let's say the teacher gave them a mathematics test, and so he records their score in the test and the number of days they were absent from school. Now, in both cases, what the teacher is trying to do here is that he is trying to establish some kind of relationship or link or a connection between the two variables that he's measuring. So in the first case, the variables are the age and the height. He's trying to see whether there is some kind of connection or some kind of link between ages and height. Is there any connection? Is there any relationship between ages and height? How does age affect height? In the second case, he's trying to see whether there is some kind of relationship or a connection between the score of the students in the test and the number of days they were absent from school. If we consider the first case, which is the ages and height, you realize that generally, as people age, their height also increases. So you realize that as the ages increase, the height increase. Of course, that is not true all the time. There are some people that are taller even though they are very young, and there are some people that are shorter even though they are quite old. But generally, you realize that as age increases, height also increases. In the second case, it's very likely that the teacher is going to find out that as the number of days of absence from school increases, the mathematics score decreases, because if the student is absent from school for quite a number of days, then it's likely that they missed out on the mathematics class, and so they did not understand the lesson, and as a result, they performed quite poorly in the exam. And so in the second scenario, you realize that as the number of days of absence increase, the mathematics score reduces. So you can see that in both scenarios here, there is a relationship that exists between the variables, but there are two different kinds of relationships. For the first one, as one variable increases, the other increases. As the age increases, the height increases. For the second one, as one variable increases, the other decreases. So as the number of days of absence increases, the score in the mathematics test decreases. Correlation is a measure of the direction and strength of the relationship that exists between the variables measured. So correlation helps us to answer the question, is there a relationship at all? If there is a relationship, what is the strength of that relationship? How strong is the relationship? What is the direction of the relationship? Is it such that as one increases, the other decreases, or as one decreases, the other increases? Correlation helps us to answer these questions. One, it helps us to establish whether there is any form of relationship at all, and if there is, what is the strength of that relationship, and also what is the direction of that relationship. That is the kind of information correlation helps us to obtain about the data that we have collected. What about regression? Regression analysis helps in predicting how a change in one variable affects the other variable. So for regression analysis, it helps us to predict how a change in one variable will affect the other variable. So let's say the teacher has been able to realize that as the ages increases, the height increases. Using regression analysis, he will be able to predict that if a student is of a certain age, then his height will be of a certain meter or a certain centimeter. Regression analysis helps us to predict how a change in one variable will affect the other variable. So correlation helps us to answer the question, is there a relationship between the variables? What is the strength of that relationship? And what is the direction of the relationship? And regression analysis helps us to predict how a change in one variable affects the other variable. As you can see, the lesson is in two parts, correlation and regression. We are going to focus on correlation now. When we are done, we will talk more about regression. So let's talk more about correlation. As we have learned, correlation is a measure of the direction and strength of the relationship that exists between the variables that we have measured. Basically, we have about three main types of correlation. The first one is a positive correlation. In a positive correlation, an increase in one variable causes an increase in the other variable. So when we say a correlation is positive, what it means is that as one variable increases, the other variable also increases. When you have such a case, then it is said that you have a positive correlation. A negative correlation is the opposite of a positive correlation. So for a negative correlation, as one variable increases, the other variable decreases. For a positive correlation, as one variable increases, the other variable increases. But for a negative correlation, as one variable increases, the other variable decreases. We also have what we call a zero correlation. Sometimes the data that you collect can be such that you can't draw any recognizable pattern. You can't really tell whether it's positive or it's negative. You can't tell whether as one variable increase, the other increase, or as one increase, the other decrease. You can't really draw any reasonable conclusion from the data. When you have such a data, you say that the correlation is a zero correlation. So the correlation could be positive, where as one variable increases, the other increases, or it could be negative, where as one variable increases, the other decreases, or you could have a zero correlation where there is no recognizable pattern, so you can't really tell whether it is a positive correlation or a negative correlation. For a given data, we can analyze the data to find a certain constant about it. That constant helps us to determine the direction and strength of the relationship that exists between the variables. We can analyze the data to get a certain constant, and that constant helps us to determine the direction and strength of the relationship between the variables. Basically, that constant helps us to answer all the questions that correlation asks. And that constant is known as the coefficient of correlation. When we have a data set, we can find the coefficient of correlation. The coefficient of correlation is a numerical value. It's a number. It's a numerical value that shows the strength and direction of the correlation. So when we find the coefficient of correlation for a given data, it helps us to know the strength of the relationship. How strong is it? Is it very strong? Is it moderate? Is it very low? It also helps us to know the direction. Is it a positive correlation? Is it a negative correlation? Or is it a zero correlation? The coefficient of correlation helps us to answer all these questions. Let's learn more about the coefficient of correlation. It is usually represented by the small letter r. So in most books, you see it as small r. It lies between -1 and 1. And so r is greater than or equal to -1, but less than or equal to 1. What it means is that r can't be less than -1, and it can't be more than 1. The lowest it can be is -1, and the highest it can be is 1. When r is equal to 1, it means that the data has a perfect positive correlation. If r is equal to -1, what it means is that the relationship that exists between the data points is negative and is perfect. It is a perfect negative correlation. And when r is 0, it means that there is zero correlation. There is no correlation at all. In real life, all the data points that you collect, in real life, you will never have a perfect positive correlation. It doesn't exist. Neither would you have a perfect negative correlation. That one also doesn't exist. And you rarely have a zero correlation. So for all the data points that we collect, we realize that the coefficient of correlation will usually be between -1 and 1. We are going to learn what it means when the coefficient of correlation is between -1 and 1. Generally, if r is between 0 to 0.2, it implies a very weak or negligible correlation. If r is between 0.2 to 0.4, it implies a weak or low correlation. If r is between 0.4 to 0.7, it implies a moderate correlation. If r is between 0.7 to 0.9, it implies a strong or high correlation. And if r is between 0.9 to 1.0, it implies a very strong or very high correlation. So as you can see, depending on the value of r, we can determine the strength of the correlation, and then also depending on the sign, whether it is positive or negative, we can determine the direction of the correlation. Take note that what I have listed here applies to both negative and positive values of r. Now that we have all this information about the coefficient of correlation r, let's learn how to find it. There are quite a number of ways to find the coefficient of correlation. In this lesson, we are going to learn about one of them. It is called the Spearman's rank correlation coefficient. The Spearman's rank correlation coefficient. For a set of paired data, xy, Spearman's rank correlation coefficient, Rs, is given by Rs is equal to 1 minus 6 sigma d squared divided by n into bracket n squared minus 1. If you have a set of paired data, so you have a data set that has 2 points. One set of points is called x and the other set of points is called y. If you have a data set like that, then you can find the Spearman's rank correlation coefficient, which is represented by r subscript x and is given by the formula 1 minus 6 sigma d squared divided by n into bracket n squared minus 1. We can use this formula to find the Spearman's rank correlation coefficient, which will help us to determine the direction of the correlation and also the strength of the correlation. Let's find out what D and N mean. N is the number of pairs of data. So let's say if the data sets that you have 9 pairs of data, then N is 9. If you have 7 pairs of data, then N is 7. We are going to solve some questions with this so you understand what all of this means. And D is obtained by ranking the x values and the y values among themselves, usually from high to low, and finding the difference between the ranks. So the D is the difference between the ranks of the X values and the Y values. So you rank the X values and you rank the Y values. You assign a rank to them and then you find the difference between the ranks. As I said, we are going to solve some questions with this so you understand what that means. This is the formula we use to find the Spearman's rank correlation coefficient. The N is the number of pairs of data and the D is the difference between the ranks assigned to the X values and the ranks assigned to the Y values. Let's solve some questions with this. It will help you to understand it. Let's consider this question. The marks scored by students in mathematics and physics are shown in the table below. Calculate the Spearman's rank correlation coefficient. So we have the table here. We have mathematics and then physics. For mathematics, we have 3, 4, 2, 1. For physics, we have 4, 3, 1, 2. We are going to calculate the Spearman's rank correlation coefficient for this data set. Let's do that. Remember that the formula is 1 minus 6 sigma d squared divided by n into bracket n squared minus 1. To find the Spearman's rank correlation coefficient, that's what you do. You draw a table with 6 columns. The first one, you have the data points for mathematics. The second one, you have the data point for physics. The third one is Rx. That's where we are going to rank the X values. The fourth one is Ry. That's where we are going to rank the Y values. The fifth one is D. That will be the difference between the X values and then the Y values. And the sixth one will be D squared. So we will square all the D values. This is the data points given to us in the table. So for mathematics, we have 3, 4, 2, 1. And so you list them vertically here. 3, 4, 2, 1. For physics, we have 4, 3, 1, 2. You list them vertically here. 4, 3, 1, 2. Okay. I assigned mathematics X and physics Y. You can interchange it. You can assign physics X and mathematics Y. You end up getting the same thing. Okay. Here, because mathematics comes first, I'm assigning X to it, and physics comes second, I'm assigning Y to it. Now, let's come to Rx. We are going to rank the X value. This is what it means. We are going to arrange them from highest to lowest. It's like how when you write an examination, your teacher will award ranks. So the one who scored the highest will be in the first place. The one who scored the next will be in the second place, and then the next after that will be third, and the next after that will be fourth, and so on and so forth. So it's the same thing. We are going to rank the X values here. So we will look through the X values. The highest will be first place. So you give that number 1. The next one will be second place. So that will be number 2. The next one will be third place. So that will be number 3. The next one will be fourth place. So that will be number 4. Since we have only 4 values here, you are going to have up to 4. Okay. So let's do that. I'm going to clean the physics value so that we can concentrate on the mathematics. So when we look through the mathematics values, the highest is 4. So that will be number 1. So that will have a rank of 1. The next one after that will be 3. So that will be number 2. The next one after that will be 2. So that will be number 3. And the last place will be 1. And that will be number 4. So it's just like how you are ranking a set of students after an examination. The one who scored the highest will be first place, so that will be number 1. The one after that will be the second place, so that will be number 2. Then one after that will be the third place, that will be number 3. The one after that will be the fourth place, so that will be number 4. So these are the ranks for X. You do the same thing for Y. So I'll bring the Y values. I'm going to clean this so that we can concentrate on the Y values. So you rank them in the column for RY. We do the same thing. 4 is the highest, so that will be number 1. 3 is the next after 4, so that will be number 2. 2 is the next after 3, so that will be number 3, and 1 is the last place, so that will be number 4. I'll bring my mathematics values and then the Rx values back. So the Rx gives us the ranks for X, the Ry gives us the ranks for Y. After finding Rx and Ry, D is the difference between Rx and Ry. So D will be Rx minus Ry. So here you have 2 minus 1, which is 1. The next one will be 1 minus 2, which is negative 1. The next one will be 3 minus 4, which will be negative 1. And the next one will be 4 minus 3, which is 1. Now for D squared, we will square the D values here. 1 squared is 1, negative 1 squared is 1, negative 1 squared is 1, and 1 squared is 1. From the formula, we need sigma D squared, so we have to find the sum of the values in the column for D squared. 1 plus 1 plus 1 plus 1 gives us 4, so sigma D squared is 4. The coefficient of correlation, the Spearman's rank coefficient of correlation, is given by the formula 1 minus 6 sigma D squared divided by n into bracket n squared minus 1. Now, what is n? N is the number of data points. The number of data points. You see here, we have 4 data points. The first one, we have 3 and 4, that's 1. 4 and 3, that's another 1. 2 and 1, that's another 1. And 1 and 2, that's another 1. So we have 4 data points. That's what the question gave us. In the question, we had 4 data points in the table. So n is 4. N is always the number of data points. And so here, n is 4 and sigma D squared is also 4. So you substitute that into the formula. When you do that, we have 1 minus 6 times 4 divided by 4 times 4 squared minus 1. And this gives us 0.6. So it means that for the given set of data, that's for the data set given to us, the Spearman's rank correlation coefficient is 0.6. Let's consider another question. In an examination, candidates were ranked in mathematics and English as shown in the table. So in the table, we have the scores for mathematics and for English. The first part of the question says we should calculate the Spearman's rank correlation coefficient. And the second part of the question says we should interpret our answer. So let's begin with the first part, calculating the Spearman's rank correlation coefficient. To do that, we will draw a table with 6 columns, as you can see here. The first one will be the scores for mathematics. I'll call that X. The second one will be the scores for English. I'll call that Y. The third one will be the ranks for X. That will be Rx. The fourth one will be the ranks for Y. That will be Ry. The fifth one will be D, the difference between Rx and Ry. And the last one will be D squared, the square of the D values. We will now list the mathematics scores here, and we will list the English scores here. We are going to find Rx, which is the ranks for X. So I will take the Y values away so that we can concentrate on the X values. That's the score for mathematics. We are going to rank them. Just as we did in the previous example, we will go through the scores and we will rank them from highest to lowest. So the highest score will have a rank of 1. The one after that will have a rank of 2. And then the next one will be a rank of 3 and so on. When we go through the X values, we can see that the highest one is 10. So that will have a rank of 1. The next one is 9. That will have a rank of 2. The next one is 8. That will have a rank of 3. The next one is 7. That will have a rank of 4. The next one is 6. That will have a rank of 5. The next one is 5. That will have a rank of 6. The next one is 4. That will have a rank of 7. The next one is 3. That will have a rank of 8. The next one is 2. That will have a rank of 9. And the last one is 1. That will have a rank of 10. Now, let's rank the y values. I'll take off the mathematics scores and then the Rx values so that we can fully concentrate on the y values and rank them. The highest one amongst them is 10, so that will have a rank of 1. The next one after that is 9, that will have a rank of 2. The one after that is 8, that will have a rank of 3. The one after that is 7, that will have a rank of 4. The one after that is 6, that will have a rank of 5. The one after that is 5, that will have a rank of 6. The next one is 4, that will have a rank of 7. The next one is 3, that will have a rank of 8. The next one is 2, that will have a rank of 9. And the last one is 1, that will have a rank of 10. So now we have the Rx values and then the Ry values. You can see that in the previous example and in this example, I ranked the scores from highest to lowest. So the highest one has a rank of 1, the next one a rank of 2, and then the lowest score will have the lowest rank. You can also choose to rank it from lowest to highest. So in that case, the lowest one will have a rank of 1. So someone can decide that 1 will have a rank of 1, 2 will have a rank of 2, 3 will have a rank of 3, 4 will have a rank of 4, up to the highest one. But remember that if you do that for the x values, you have to do the same thing for the y values. So when you are ranking the scores, you can either choose to rank from lowest to highest or from highest to lowest. But remember that if you choose to rank from highest to lowest, then you have to rank the x values from highest to lowest and the y values from highest to lowest. If you choose to rank from lowest to highest, then you have to rank the x values from lowest to highest and then the y values from lowest to highest. Okay. Here we have our Rx values and we have our Ry values, so we can find the D values. To get the first D value is going to be Rx minus Ry. So 2 minus 6, that will give us negative 4. The next one will be 5 minus 4, that is 1. The next one is 4 minus 10, that is negative 6. The next one is 9 minus 7, that is 2. The next one is 6 minus 1, that is 5. The next one is 10 minus 8, that is 2. The next one is 3 minus 9, that is negative 6. 8 minus 3 gives us 5. 1 minus 5 gives us negative 4. And 7 minus 2 gives us 5. We have the D values here, so we can now find the D squared values. So you have negative 4 squared, that will be 16. 1 squared is 1. Negative 6 squared is 36. 2 squared is 4. 5 squared is 25. 2 squared is 4. Negative 6 squared is 36. 5 squared is 25. Negative 4 squared is 16. And 5 squared is 25. We need sigma D squared, so we add all the values in this column, the column for D squared. When we do that, we have 188. So sigma D squared is 188. The formula for finding the Spearman's rank correlation coefficient is Rs is equal to 1 minus 6 sigma D squared divided by n into bracket n squared minus 1. We have found sigma D squared here, we had 188. N is the number of data points. See, from the table we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data points, and so n is equal to 10. So we will substitute sigma D squared and n here. When we do that, we have 1 minus 6 times 188 divided by 10 times into bracket 10 squared minus 1. And this gives us negative 0.14. So the Spearman's rank correlation coefficient for the data given to us is negative 0.14. The second part of the question says we should interpret our answer. What that means is that we should describe what the answer tells us about the correlation. what it tells us about the direction of the correlation and the strength of the correlation. As you can clearly see, the Spearman's rank correlation coefficient we have here is a negative number, meaning that the correlation is negative. And we have also learned that depending on the range within which the correlation falls, we can describe the strength of the correlation. Here, our Spearman's rank correlation coefficient is negative 0.14. The negative tells us that it is in the negative direction, which means that as one value increases, the other decreases. So we have a negative correlation here. Now, the value here is 0.14. So we will look through these ranges and find which one 0.14 falls within. As you can see, 0.14 will fall within the first one, 0 to 0.2. 0.14 falls within this range. And if the correlation coefficient falls within this range, it means that the correlation is very weak or negligible. And so here, it means that this correlation is very weak and negligible, and it is also negative. And so we can say that the correlation between the mathematics and English scores of the candidates is negative and very weak or negligible. Let's consider another question. 5 finalists in a beauty pageant were ranked by 2 judges X and Y as shown in the table. In the table, we have Judge X, Judge Y, and these are the finalists: Anne, Linda, Susan, Rose, and Erica. And these are the scores that the judges assigned to the finalists. The question says we should calculate the Spearman's rank correlation coefficient. We will draw a table with 7 columns. In the first column, we will list the finalists. We have Anne, Linda, Susan, Rose, and Erica. The second column will be for X. So this will contain the scores for Judge X. And the third column will be for Y. That will contain the scores for Judge Y. Rx will be the rankings for the X values. And then Ry will be the rankings for the Y values. D will be the difference between Rx and Ry. And D squared will be the square of the D values. From the table given to us, these are the scores for Judge X. We have 1, 4, 3, 5, 2. And these are the scores for Judge Y, 3, 2, 4, 5, 1. In Rx, we are going to rank the X values. I will take the Y values away so that we can focus on the X values. So the highest number, we will give it a rank of 1. The one after that, we'll give it a rank of 2, just as we have been doing. When we look through X, the X values, the highest value is 5. So that will have a rank of 1. The next one is 4. That will have a rank of 2. The next one is 3. That will have a rank of 3. The next one is 2. That will have a rank of 4. And the last one is 1. That will have a rank of 5. I'll bring back the Y values. We have 3, 2, 4, 5, 1. We are going to rank them. When we look through it, the highest one is 5. That will have a rank of 1. The next one is 4. That will have a rank of 2. The next one is 3. That will have a rank of 3. The next one is 2. That will have a rank of 4. And the last one is 1. That will have a rank of 5. We can now find our D values. D will be equal to Rx minus Ry. 5 minus 3 will give us 2. 2 minus 4 will give us negative 2. 3 minus 2 will give us 1. 1 minus 1 gives us 0. And 4 minus 5 gives us negative 1. To get D squared, we will square the D values here. 2 squared will give us 4. Negative 2 squared gives us 4. 1 squared is 1. 0 squared is 0. And negative 1 squared is 1. We need sigma D squared. So we will sum all the D square values. 4 plus 4 plus 1 plus 0 plus 1 gives us 10. So sigma D squared is 10. The Spearman's rank correlation coefficient is given by the formula Rs is equal to 1 minus 6 sigma D squared divided by N into bracket n squared minus 1. N here will be the number of finalists. Let's count them. We have 1, 2, 3, 4, 5. We have 5 finalists, so n is 5. We have sigma d squared to be 10, so we substitute that information here. When we do that, we have 1 minus 6 times 10 divided by 5 times into bracket 5 squared minus 1, and this gives us 0.5. So the Spearman's rank correlation coefficient for the data given to us is 0.5. Let's consider another question. 7 participants in an art contest were ranked by 2 judges as follows. In the table here, we have the participants A, B, C, D, E, F, G. And these are the scores for the first judge, and these are the scores for the second judge. The question says that calculate, correct with 3 decimal places, the Spearman's rank correlation coefficient for the scores of the judges. That's the first part of the question. And the second part of the question says we should comment on our results. So let's begin with the first one. We will draw a table with 7 columns. The first column will be for the participants, A, B, C, D, E, F, G. The second column will be the scores for the first judge. I'll call that X. The third column will be the scores for the second judge. I'll call that Y. We have Rx, where we rank the X values. We have Ry, where we rank the Y values. And then we have D, which will be the difference between Rx and Ry, and D squared, which will be the square of the D values. These are the scores for the first judge, and these are the scores for the second judge. Let's rank the scores for the first judge. The highest one will have a score of 1, the one after that will be 2, and the one after that will be 3, and so on, just as we have been doing. When we look through them, the highest one is 7, so that will have a rank of 1. The one after that is 6, that will have a rank of 2. The next one is 5, that will have a rank of 3. The next one is 4, that will have a rank of 4. The next one is 3, that will have a rank of 5. The next one is 2, that will have a rank of 6. And the last one is 1, that will have a rank of 7. Now let's rank the scores for the second judge. These are the scores. We are going to rank them here in the column for Ry. The highest one is 7, so that will have a rank of 1. The one after that is 6, that will have a rank of 2. The one after that is 5, that will have a rank of 3. The one after that is 4, that will have a rank of 4. The one after that is 3, that will have a rank of 5. The next one is 2, that will have a rank of 6. And the last one is 1, that will have a rank of 7. We can now find our D values. The D values will be the difference between Rx and Ry. So D will be equal to Rx minus Ry. 5 minus 5 gives us 0. 4 minus 2 gives us 2. 7 minus 6 gives us 1. 2 minus 3 gives us negative 1. 3 minus 1 gives us 2. 1 minus 4 gives us negative 3. And 6 minus 7 gives us negative 1. Let's find D squared. 0 squared is 0. 2 squared is 4. 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 3 squared is 9. And negative 1 squared is 1. We will need sigma D squared. So we will add all the D squared values together, and that gives us 20. The Spearman's rank correlation coefficient is given by the formula Rx is equal to 1 minus 6 times sigma D squared divided by n into bracket n squared minus 1. We have sigma D squared to be 20. N will be the number of participants. Let's count them. We have 1, 2, 3, 4, 5, 6, 7. So n is 7. When we substitute that information here, we have 1 minus 6 times 20 divided by 7 times into bracket 7 squared minus 1. And this gives us 0.643. So the Spearman's rank correlation coefficient is 0.643. Now remember, the second part of the question says we should comment on our answer. We have learned that depending on the range within which the Spearman's rank correlation coefficient falls, we can comment on the strength of the correlation, and also the sign of the Spearman's rank correlation coefficient tells us the direction of the correlation. Here we have 0.643. It's a positive number, which means that this correlation is positive. And 0.643 falls within the range 0.4 to 0.7. So here we can say that the correlation is positive and moderate. So the correlation between the scores of the judges is positive and moderate. So far, in the examples that we have considered, the scores are unique, and so when we are ranking them, we can easily assign a rank to each of them. Because the scores are unique, we know which one will be in the first place, which one will be the second place, the third place, and so on and so forth. There can be a situation where 2 scores or 3 scores or sometimes even 4 scores have the same value. When it happens like that, how do you go about the ranking? We are going to consider some examples like that and learn how to find the Spearman's rank correlation coefficient in such a situation. Let's consider the next question. An aptitude test was given to 10 sales staff, and the results together with their annual sales in thousands are shown in the table below. Calculate the Spearman's rank correlation coefficient for the data. In the table, we have the test scores and we have the sales in thousands. We are going to use this information to calculate the Spearman's rank correlation coefficient. Let's do that. We will have a table with 6 columns. In the first column, we have the test scores. I'll call that X. In the next column, we have the sales. I'll call that Y. In the next column, we have Rx, where we will rank the X values. The next column we have RY, where we will rank the Y values. Then we have D, which is the difference between RX and RY, and then D squared, which is the square of the D values. Here are the test scores, and here are the sales values. Now we are going to rank the test scores. That will be RX. As you can see, some of the test scores occur more than once. So for example, 8 occurs twice, 9 also occurs twice, 12 occurs twice, and 11 occurs twice. This is quite different from the examples that we considered previously, where all the scores were unique. So when you have a case like this, how do you go about the ranking? Let's find out. What you do is that you list the numbers from highest to lowest, so in descending order. So we will go through the scores and we will list them from highest to lowest. When we go through the scores, the highest is 16, the one after that is 14, the one after that is 12, we have another 12, then we have 11 here, another 11, then the next one is 9, we have another 9, and then we have 8 and another 8. Now, after we have listed the scores from highest to lowest like this, we will assign the ranks to them. So obviously 16 is the highest, so that will be in first place. 14 is the next highest number, so that will be in second place. Now in the third place will be 12. In the fourth place will also be 12. The fifth place will be 11. Sixth place will also be 11. The seventh place is 9. Eighth place is also 9. Ninth place is 8. And the last place, or the 10th place, is also 8. From here, we can see that 16 occurs just once, and that is the highest score. So that will have a rank of 1. So we can give 16 a rank of 1 as usual from what you have been doing. The next number is 14. That will have a rank of 2. But as you can see, the third and fourth place are both occupied by the score 12. So in third place is 12 and in fourth place is also 12. When you have a situation like this, what you do is that you add the ranks and find their average. So 12 occurs twice, and so you add the ranks for those scores and then you find the average. The ranks for 12 are 3 and 4. So you add 3 to 4 and then you find the average. 3 plus 4 gives us 7. Then you divide it by 2 since 12 occurs twice. 7 divided by 2 gives us 3.5. So here 12 will have a rank of 3.5. So this first 12 will have a rank of 3.5 and this second 12 will also have a rank of 3.5. And so in the table, 12 will have a rank of 3.5 and 12 here will also have a rank of 3.5. So anytime you have a particular score occurring more than once, you add the ranks for that particular score and then you find the average. Let's move on to the next one. Now the next score is 11. As you can see, 11 also occurs twice. The rank for this is 5 and the rank for this is 6. So you add the ranks. You add 5 to 6 and then you divide it by the number of times 11 occur, which is 2. So 5 plus 6 will give us 11. Then you divide it by 2 and 11 divided by 2 gives us 5.5. So 11 will have a rank of 5.5. The first 11 here will have a rank of 5.5 and the second 11 also have a rank of 5.5. So in our table, this 11 has a rank of 5.5 and this one also has a rank of 5.5. The next score is 9. 9 also occurs twice. It occurs 2 times. The rank here is 7. The rank here is 8. So you add the ranks. 7 plus 8. 7 plus 8 gives us 15. Since 9 occurs 2 times, you divide it by 2. So 15 divided by 2 gives us 7.5. And so this 9 will have a rank of 7.5 and this 9 will also have a rank of 7.5. So in our table, 9 here will have a rank of 7.5 and 9 here also have a rank of 7.5. The next score is 8. 8 also occurs twice. This 8 has a rank of 9 and this one a rank of 10. So you add the ranks. 9 plus 10 and that gives us 19. Then since 8 occurs 2 times, you divide that by 2. 19 divided by 2 gives us 9.5. So this 8 will have a rank of 9.5 and this 8 will also have a rank of 9.5. So from our table, 8 here will have a rank of 9.5 and 8 here will have a rank of 9.5. So this is how to rank the scores when a particular score occurs more than once. You add the ranks for that particular score and then you find the average, just as we have done here. Let's rank the Y values. Here are the Y values. As you can see, some of the scores occur more than once. I can see 25 and 25 here. And so what I will do is that I will list the scores from highest to lowest. When we go through it, the highest one is 40. The one after that is 32. The one after that is 30, and then 29, and 28, and then 26, 25, and then 25 again, then 22, and the last one is 20. Then we will assign the ranks to it. 40 is the highest, so that will be 1. The next one will be 2, the next one 3, 4, 5, 6, 7, 8, 9, 10. Now from the table we can see that 40 occurs just once, so that will have the rank of 1, and so 40 will be in first place, rank 1. 32 also occurs once, so it will have a rank of 2. 30 will have a rank of 3, it occurs just once. 29 will have a rank of 4. 28 will have a rank of 5. 26 will have a rank of 6. Now 25 occurs twice, and the rank here is 7, the rank here is 8. And so what we will do is that we will add the ranks, and then we will divide it by 2, since 25 occurs twice. 7 plus 8 gives us 15, and 15 divided by 2 gives us 7.5. So this 25 will have a rank of 7.5, and this 25 will also have a rank of 7.5. Then the next score is 22. It has a rank of 9. It occurs just once, so a rank of 9. And then 20 has a rank of 10. It's in last place, so that will have a rank of 10. Now I'll bring the test scores and then the RX values back so that we can find the D. To get the D, we will subtract RY from RS. 9.5 minus 10 gives us negative 0.5. 7.5 minus 7.5 gives us 0. 3.5 minus 3 gives us 0.4. 5.5 minus 4 gives us 1.5. 9.5 minus 9 gives us 0.5. 5.5 minus 5 gives us 0.5. 2 minus 2 gives us 0. 1 minus 1 gives us 0. 3.5 minus 7.5 gives us negative 4. 7.5 minus 6 gives us 1.5. We will find D squared by squaring the D values. Negative 0.5 squared gives us 0.25. 0 squared is 0. 0.5 squared gives us 0.25. 1.5 squared gives us 2.25. 0.5 squared gives us 0.25. 0.5 squared is 0.25. 0 squared is 0. 0 squared is 0. Negative 4 squared gives us 16. And 1.5 squared gives us 2.25. We need sigma D squared. You add all the D squared values here, and that gives us 21.5. The Spearman's rank correlation coefficient is given by the formula RS is equal to 1 minus 6 times sigma D squared divided by n into bracket n squared minus 1. We have the sigma D squared to be 21.5. The n is the number of data points. From here, from the table, you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data points, so n is 10. And so we can substitute that information here. When we do that, we have 1 minus 6 times sigma D squared is 21.5, so 21.5 divided by n is 10, so 10 times into bracket 10 squared minus 1. And this gives us 0.87. So the Spearman's rank correlation coefficient for the data is 0.87. Let's consider another question. The table below shows the heights x and hip sizes y of some cows. Calculate the Spearman's rank correlation coefficient between the heights and hip sizes. Let's do that. So we have a table with 6 columns. In the first column, I'll have the heights, I'll call that x. In the second column, I'll have the hip sizes, I'll call that y. We have Rx where we rank the x values, Ry where we rank the y values. D will be Rx minus Ry, and D squared will be the square of the D values. Here are the x values from the table, the heights. And here are the hip sizes, that's the y values from the table given to us. Now let's begin by ranking the x values. As you can see from the values, some of them occur more than once, and so you have to rank them differently as compared to what you have been doing all along. So what I will do is that I will list them from highest to lowest. From the table, you can see that the highest one is 1.7. There's another 1.7. And then after that, the next one is 1.6, and the one after that is 1.5. There are 4 of the 1.5s. So we have 1.5, 1.5, 1.5, and 1.5. The 1.4 occurs 2 times. So we have 1.4, 1.4, and then the least value here is 1.3. Now let's assign the ranks to them. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, from here, we can see that in first place and second place is 1.7. The score 1.7 occurs twice. So what you do is that you will add the ranks for the two 1.7s. The first one is 1 and the second one is 2. You add the ranks, 1 plus 2. And then we will divide it by 2 since the 1.7 occurs twice. So 1 plus 2 gives us 3. 3 divided by 2 gives us 1.5. So this 1.7 will have a rank of 1.5. And then this 1.7 will also have a rank of 1.5. Then the next value is 1.6. It occurs just once and the rank is 3. And so that's what we assign to it. 1.6 will have a rank of 3. Then the next value is 1.5. The 1.5 occurs 4 times. And so you add those 4 ranks and then divide it by 4. We are finding the average. It occurs 4 times. And so you add those 4 ranks and then you divide it by 4. 4 plus 5 plus 6 plus 7 gives us 22. 22 divided by 4 gives us 5.5. And so this 1.5 will have a rank of 5.5. The same goes for this one, 5.5. The same goes for this one, 5.5. And this one, 5.5. Then we go on to the next value, which is 1.4. 1.4 occurs twice. The rank for this one is 8 and the rank for this one is 9. You add those 2 ranks and divide it by 2 since it occurs twice. 8 plus 9 gives us 17. 17 divided by 2 is 8.5. So for this 1.4, it will have a rank of 8.5. And this 1.4 will also have a rank of 8.5. The last value is 1.3. It has a rank of 10. So that will be here, 10. So anytime a particular score occurs more than once, you add the ranks for that particular score and then you find the average. Let's rank the y values. Here are the y values. We are going to rank them here. We will list them from highest to lowest. The highest one is 0.30. The one after that is 0.29. The one after that is 0.28. And then 0.27, 0.25, 0.24, another 0.24, 0.22, 0.22, and the last one is 0.22. Then we will assign the ranks to them. This one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.30 occurs just once and it has a rank of 1, and so it will have the rank 1. 0.29 also occurs just once and it has a rank of 2, and so in the table it will have a rank of 2. The same goes for 0.28. It occurs just once, it has a rank of 3, and so it will have a rank of 3 here. 0.27 occurs just once, it has a rank of 4, and so it will have a rank of 4 here. The same applies to 0.25. It occurs just once and it has a rank of 5, and so it will have a rank of 5 here. But 0.24 occurs twice. This one has a rank of 6 and this a rank of 7. So you add those 2 ranks and you divide it by 2 since 0.24 occurs twice. 6 plus 7 gives us 13. And 13 divided by 2 is 6.5. And so this 0.24 will have a rank of 6.5. And this 0.24 will also have a rank of 6.5. Now 0.22 occurs 3 times. The first one has a rank of 8, the next one a rank of 9, and the last one a rank of 10. And so you add the ranks and then you find the average. Since it occurs 3 times, you divide it by 3. So you add the ranks, 8 plus 9 plus 10. Then you divide it by 3. 8 plus 9 plus 10 gives us 27. And 27 divided by 3 gives us 9. So this 0.22 will have a rank of 9. The same goes for this one, a rank of 9. And the same goes for this one, a rank of 9. Now we have our Rx values and our Ry values. And so we can find the D values. D is equal to Rx minus Ry. 5.5 minus 4 gives us 1.5. 8.5 minus 1 gives us 7.5. 5.5 minus 6.5 gives us negative 1. 3 minus 9 gives us negative 6. 1.5 minus 3 gives us negative 1.5. 10 minus 2 gives us 8. 5.5 minus 9 gives us negative 3.5. 5.5 minus 9, negative 3.5. 8.5 minus 6.5 gives us 2. 1.5 minus 5 gives us negative 3.5. For the d squared values, you square the d values here. 1.5 squared is 2.25. 7.5 squared is 56.25. Negative 1 squared is 1. Negative 6 squared is 36. Negative 1.5 squared is 2.25. 8 squared is 64. Negative 3.5 squared is 12.25. Negative 3.5 squared, another 12.25. 2 squared is 4. Negative 3.5 squared is 12.25. We need a sigma d squared, and so you add all the d squared values, and that gives us 202.5. The Spearman's rank correlation coefficient is given by the formula Rx is equal to 1 minus 6 times sigma d squared divided by n into bracket n squared minus 1, where n is the number of data points. Here from the table, the data points are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 in number, and so n is equal to 10. We have found sigma d squared to be 202.5, and so you substitute that information here. When you do that, you have 1 minus 6 times 202.5 divided by 10 times into bracket 10 squared minus 1, and this gives us negative 0.23. So the Spearman's rank correlation coefficient for the data is negative 0.23. And so this is how to find the Spearman's rank correlation coefficient for a given data when a particular score occurs more than once. You add the ranks for that score and then you find the average. So far, we have solved quite a number of questions on finding the Spearman's rank correlation coefficient for a given data. At the beginning of this lesson, we learned that our lesson is in two parts, correlation and regression. So far, we have been considering correlation. Now, let's turn our attention to the second part of the lesson, which is regression. At the beginning of the lesson, we learned that regression analysis helps in predicting how a change in one variable affects the other variable. And so, with regression analysis, we will be able to predict how one variable will change as the other changes. In order to do this, we usually plot the data points in the XY plane on a graph sheet. When the data points obtained from the survey are plotted on the XY axis, the diagram produced is called a scatter diagram. So when you plot the data points that you collect from the survey on the XY axis, the diagram that you produce is called a scatter diagram. It looks something like this. You have your y values here and you have your x values here. When you plot them, it can look something like this. Now, from what you have here, you can see that generally, as the y values increases, the x values also increases. So this signifies a positive correlation. When the data points that you have shows a positive correlation, your scatter diagram looks like this. Once again, scatter diagram is the name given to the graph that you obtain when you plot the data points. When it's a positive correlation, it looks like this. Sometimes it can also look like this. You have the y values here and then the x values here. From here, you can see that as the y values decreases, the x values increases. When the scatter diagram looks like this, it shows a negative correlation. As we learned in the beginning of the lesson, For a negative correlation, as one variable decreases, the other variable increases. If the data points given to you shows a negative correlation, your scatter diagram will look like this. As the y value decreases, the x values increases. Sometimes the scatter diagram can also look like this. When it's like this, it shows a zero correlation. You can't really draw any meaningful conclusion from it. It doesn't show a positive correlation, it doesn't show a negative correlation. The points are just scattered, as you can see here. This is how the scatter diagram looks like. If it's a positive correlation, it will look like this. If it's negative, it looks like this. And when it's a zero correlation, it looks like this. Let's learn more about it. On the scatter diagram, a line that best describes the relationship between the data points is known as the line of best fit or the regression line. Now, this is what this point means. Let's assume that this is a scatter diagram for a particular data. These are your y values and these are your x values. When we obtain the scatter diagram like this, we usually want one line or a line that best describes the data points. So as you can see, the points are clearly scattered. They are all not in a straight line. And so we usually want one line that best describes the behavior of the data points, that best describes the relationship or the connection between the data points. And that line is known as the line of best fit or the regression line. So for example, with a data point like this, we can draw a line like this. And this line is known as the line of best fit or the regression line. This regression line or the line of best fit helps us to be able to predict how one variable will change as the other changes. This regression line or line of best fit best describes the relationship between the data points. Now, we are going to learn how to draw this line of best fit. How do we know where to draw the line? As you can see, the data points are clearly scattered, and so how do we choose the particular data points we are going to draw the line through? How do we draw the line of best fit or the regression line? That is what we are going to learn. The line of best fit or the regression line. There are three commonly used methods in drawing the line of best fit. They are by inspection, using the semi-averages method, and using the least squares method. So we can draw the line of best fit using any of these three methods. The first one is by inspection, the second one is by using the semi-averages method, and the third one is by using the least squares method. We are going to learn how to use each of them. We begin with the first one, by inspection. Drawing the line of best fit by inspection. Generally, when you are required to draw the line of best fit by inspection, after plotting the data points on the graph sheet to get the scatter diagram, you will find the mean of all the x values, that is the x mean, shown as x with a bar on top of it. And you also find the mean of all the y values, that is the y mean, shown as y with a bar on top of it. And after you have done this, you plot the x mean, y mean. You have the value for x mean and you have the value for y mean. So you plot it on the scatter diagram and you draw the line through it. So after plotting the data points to get the scatter diagram, you find the mean of the x values, you call that the x mean. You find the mean of the y values, you call that the y mean. Then you plot the point x mean, y mean on the scatter diagram and you draw the line through it. When drawing the line, you need to take note of the following. The first one is that the line should have as many points on it or close to it as possible. As I've indicated here, you are going to draw the line through the point x mean, y mean. While doing that, you need to make sure that the line passes through as many points as possible, or you have as many points as possible close to it. So you draw the line in such a way that most of the data points will fall on it, or most of the data points will be close to it. Here's another point you have to take note of. The line should have the same number of plotted points above and below it. So you should draw the line in such a way that the data points that you have plotted, you have the same number of it above it and below it. So if you have 3 data points above it, you should also have 3 data points below it. But you should ignore wide points. Sometimes some of the data points are so wide, they are far above or far below. Those points you have to ignore it. So here are the points that you need to take note when drawing the line of best fit by inspection. You find the mean of the x values, we call that the x mean. You find the mean of the y values, you call that the y mean. And then you plot x mean, y mean on the scatter diagram. And after you have done that, you draw the line through it. But you need to take note of the following. The line should have as many points on it or close to it as possible. And the line should have the same number of plotted points above it and below it. But if there are any wide points, you have to ignore them. Questions that require you to draw the line of best fit can be asked in different ways. We are going to consider some of them. Let's consider the first one. The marks of 10 students in physics and chemistry are in the table below. We have the physics marks here and the chemistry marks here. A. Plot a scatter diagram to represent this information. B. Find x mean, the mean of x, and y mean, the mean of y, and plot x mean, y mean on the diagram. C. Draw the line of best fit to pass through x mean, y mean. D. From your graph, determine I, the relationship between x and y, and II, the mark obtained in chemistry by a student who obtained 9 in physics. So this is an example of a question where you are being asked to draw the line of best fit by inspection. As you can see, the question says after plotting the scatter diagram, we should find the x mean, y mean, and then you draw the line of best fit through x mean, y mean. This shows that we are drawing the line by inspection. Let's start with the solution. The first part of the question says you should plot a scatter diagram to represent this information. As I've already explained, the scatter diagram is the diagram you obtain when you plot the data points on the graph sheet. And so here, you choose an appropriate scale and plot these points. The physics marks will be on the x-axis and the chemistry marks will be on the y-axis. Here is my graph. On the x-axis, I'm choosing a scale of 2 centimeters to 2 units. And on the y-axis, I'm choosing a scale of 2 centimeters to 2 units. Here are the points. So you take them one after the other and you plot them. The first one is 15, 20. So 15 on the x-axis and 20 on the y-axis. That will be here. The next one is 13, 12. 13, 12 will be here. The next one is 14, 18. 14, 18 will be here. The next one is 10, 10. 10, 10 will be here. The next one is 12, 6. 12, 6 is here. The next one is 8, 12. 8, 12 will be here. The next one is 10, 14. 10, 14 is here. The next one is 8, 7. 8, 7 is here. The next one is 10, 3. 10, 3 is here. And the last one is 8, 1. 8, 1 is here. I've already explained how to choose a scale for your graph, how to plot points on the graph sheet, and how to choose an appropriate position for the x and y axis in a series of videos. I will insert the link to that video in the description of this video. So if you have a problem with how to choose a scale for your graph, how to plot points on the graph sheet, or how to choose the best position for your x and y axis, you can check that video out. Now we have the scatter diagram here. We have plotted the points on the graph sheet. So this is our scatter diagram. Let's move on to the next part of the question. it says that we should find x mean, that is the mean of x, and y mean, the mean of y, and plot them on the diagram. This is the table of values. These are x values and these are y values. We are going to find the mean of x. To get the mean of x, we will add all the x values and we divide it by their number. They are 10 in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get the mean, we will add all the x values and we divide it by 10. So we have 15 plus 13 plus 14 plus 10 plus 12 plus 8 plus 10 plus 8 plus 10 plus 8 divided by 10. And this gives us 10.8. Then we will find y mean. To get the y mean, we will add all the y values and we divide it by 10 since they are 10 in number. So you have 20 plus 12 plus 18 plus 10 plus 6 plus 12 plus 14 plus 7 plus 3 plus 1. You divide that by 10 and that gives us 10.3. The x mean is 10.8. The y mean is 10.3. We will plot this on the scatter diagram and then after that we will draw the line of best fit through it. Let's plot it. 10.8 on the x-axis and 10.3 on the y-axis will be here. So there's the point 10.8, 10.3. Now we will draw the line of best fit through this point. Remember the conditions. It should pass through as many points as possible and the number of points above it and the number of points below it should be the same. And so I'll draw my line of best fit here. It passes through 10.8, 10.3. This point is almost on the line. This point is on the line. Now look at it. I have 1, 2, 3, 4 points above it, and below it I have 1, 2, 3, 4. So you see I have the same number of points above it and the same number of points below it. So whenever you are drawing the line of best fit by inspection, you have to make sure that as many points as possible fall on it. Here I have 2 of the data points falling on it, and then I have 4 of the data points above it and 4 of the data points below it. Someone might choose a direction for his line of best fit that is slightly different from this, but you have to make sure that as many points as possible fall on the line and the number of points above it and the number of points below it are the same. Let's move on to the next part of the question. The next part of the question says that from your graph, determine the relationship between x and y. The relationship between x and y will be the equation of the line. When you find the equation of the line of best fit, it's going to give you the relationship between x and y. From the video on straight lines, we learned how to find the equation of a line from a graph sheet. So we are going to apply that knowledge here. This is our line. We are going to find the equation of this line. To find the equation of the line, we need the gradient of the line and we need the coordinates of at least 1 point that fall on the line. To get the gradient, I'll choose any 2 random points on the line. I'll choose this one and this one. Then I'll find the coordinates of these points. To get the coordinates, I'll trace it to the x-axis. To get the x-coordinate, I'll trace it to the y-axis to get the y-coordinate. This is giving me 10, 8. The x-coordinate is 10, the y-coordinate is 8. For this point, I'll trace it to the x-axis to get the x-coordinate. I'll trace it to the y-axis to get the y-coordinate. The y-coordinate here is 16. The x-coordinate here from my graph is 13.4. So the coordinates of this point is 13.4, 16. So I have the coordinates of 2 points that fall on the line. I can use these coordinates to find the gradient of the line. Let's do that. So from the graph, 10, 8, 13.4, 16 fall on the line. With this, I can find the gradient of the line. The gradient of the line is given by y2 minus y1 divided by x2 minus x1. Here, I'm going to choose 13.4, 16 as my x2, y2, and then 10, 8 as my x1, y1. And so y2 will be 16 minus y1, which is 8, divided by x2, which is 13.4, minus x1, which is 10. And this gives us 2.35. So the gradient of the line is 2.35. With the gradient and the coordinate of 1 point that fall on the line, we can use the equation y minus y1 is equal to m into bracket x minus x1 to find the equation of the line. Here I'm going to use the point 10, 8 as my x1, y1. M is the gradient and we have found out to be 2.35. When you substitute that here, you have y minus y1, which is 8, is equal to m, which is 2.35 into bracket x minus x1, which is 10. Let's do some simplification here. This gives us y minus 8 is equal to 2.35x minus 23.5. I'll move y and negative 8 to the right hand side. When I do that, I'm going to have 2.35x minus y minus 23.5 plus 8 is equal to 0. When you simplify this, you are going to have 2.35x minus y minus 15.5 is equal to 0. This is the equation of the line, and this gives us the relationship between x and y. So the relationship between x and y is 2.35x minus y minus 15.5 is equal to 0. We learned how to find the equation of a line from a graph sheet in the lesson on straight lines. So if you have to revise, you can go and check that out. I'll leave the link to that lesson in the description of this lesson, so you can click on it to check it out. Let's consider the last part of the question. The last part of the question says that we should determine the mark obtained in chemistry by a student who obtained 9 in physics. It says we should use the graph to determine the mark obtained in chemistry by a student who obtained 9 in physics. So what we will do is that we will come to the graph sheet, then we will look for 9 on the physics axis, which is the x-axis. You look for 9. Then you trace it to the line of best fit or the regression line. And then after that, you trace that point to the chemistry axis. When tracing to the chemistry axis here, I'm getting 5.8. This means that using the line of best fit or the regression line, if a student obtained 9 in physics, then that student is likely to obtain 5.8 in chemistry. So from the graph, the mark obtained in chemistry by a student who obtained 9 in physics is 5.8. So this is one example of how to draw the line of best fit by inspection. Let's consider another question where you have to draw the line of best fit by inspection. The table shows the height m in meters of a plant and the number of days it takes to grow. So we have the number of days here and we have the height here. Here the question has given us a scale. In the previous one, we were not given a scale. Here the question has given us a scale. If the question gives you a scale, you have to use the scale given to you. Using a scale of 2 centimeters to 0.5 units on the y-axis and 2 centimeters to 10 units on the x-axis, plot a scatter diagram. B. Draw a line of best fit. C. Use your graph to estimate the values of m and n such that y is equal to m plus nx. And II. Use your graph to estimate the height of the plant in 36 days. Unlike the previous example where we were told to draw the line of best fit through x mean and y mean, here the question did not say anything like that. It just said draw the line of best fit. When it's like this, you still have to find the x mean, you find the y mean, and then you draw the line through the x mean and y mean. We will begin with the first part of the question that says we should draw the scatter diagram. The scale has been given to us 2 centimeters to 0.5 units on the y-axis and 2 centimeters to 10 units on the x-axis. The first point is 10, 0.9. So 10 on the x-axis and 0.9 on the y-axis. That will be here. The next one is 20, 1.02. 20 on the x-axis, 1.02 on the y-axis will be here. The next one is 30, 1.20. 30 on the x-axis, 1.20 on the y-axis will be here. The next one is 40, 1.39. 40 on the x-axis, 1.39 on the y-axis will be here. The next one is 50, 1.59. 50 on the x-axis, 1.59 on the y-axis will be here. The next one is 60, 1.79. 60 on the x-axis, 1.79 on the y-axis, that will be here. The next one is 70, 2.01. 70 on the x-axis, 2.01 on the y-axis, that will be here. And the last one is 80, 2.27. 80 on the x-axis, 2.27 on the y-axis, that will be here. This is our scatter diagram. Let's move on to the next part of the question. For the next part of the question, we are being asked to draw the line of best fit. To do that, we will find our x-mean and y-mean. And then we will draw the line of best fit through the x-mean and y-mean. But remember the conditions. The line should pass through as many points as possible, and you should have the same number of points above and below it. Now let's find the x-mean and y-mean. Let's begin with the x-mean. To get the x-mean, you add all the x values and then we divide it by their number. The x values are 8. 1, 2, 3, 4, 5, 6, 7, 8. They are 8 in number. So we add 10 plus 20 plus 30 plus 40 plus 50 plus 60 plus 70 plus 80. You divide that by 8 and that gives us 45. That will be the x-mean. To get a y-mean, you add all the y values. So 0.90 plus 1.02 plus 1.20 plus 1.39 plus 1.59 plus 1.79 plus 2.01 plus 2.27. We divide that by 8 and that gives us 1.52. So we are going to plot 45, 1.52 on the scatter diagram, and then we will draw the line of best fit through this point. You plot 45, 1.52. That will be here. You draw the scatter diagram through this. Make sure that it passes through as many points as possible and you have the same number of points above and below it. Here it passes through this point. This one is very close to it. It passes through this point. I have 2 points almost above it, and here I have 2 points. This one is very close to it and this is below it. So I think this is a very good position for the line of best fit. Let's consider the next part of the question. It says that we should use the graph to estimate the value of m and n such that y is equal to m plus nx. When you look at this, y is equal to m plus nx, it's very similar to the general equation of a straight line, which is y is equal to mx plus c. So basically what the question wants us to do is to find the equation of the line of best fit that we have drawn, and then we will compare our equation to y is equal to m plus nx. Then we can get the value of m and n. So we are going to find the equation of the line of best fit that we have drawn. To get the equation, we will need the gradient and the coordinate of at least one point that falls on the line. And to get the gradient, I'll choose any 2 random points that fall on the line, and then we get the coordinates. And using the coordinates, we can get the gradient. I'll choose this point. When you trace it to the y-axis, you get 1.0. You trace it to the x-axis, you get 15. The coordinates of this point is 15, 1.0. I need another point. I'll choose this one. You trace it to the y-axis. On my graph, I'm having 1.7. You trace it to the x-axis. On my graph, I'm having 55. So the coordinates of this point is 55, 1.7. So I have the coordinates of 2 points that fall on the line, 15, 1.0, and 55, 1.7. And so 15, 1.0 or 15, 1 and 55, 1.7 fall on the line. Using this, I can find the gradient of the line. We know that the gradient of the line will be given by y2 minus y1 divided by x2 minus x1. I'm going to use 55, 1.7 as my x2, y2 and 15, 1 as my x1, y1. So y2 is 1.7 minus y1, which is 1, divided by x2 is 55 minus x1, which is 15. This gives us 0.0175. So the gradient of the line is 0.0175. Using any one of these 2 points and the gradient, we can find the equation of the line using y minus y1 is equal to m into bracket x minus x1. I'm going to choose 15, 1 as my x1, y1. So y1 will be 1. x1 will be 15. The gradient m is 0.0175. When you substitute that information here, you have y minus 1 is equal to 0.0175 into bracket x minus 15. Let's open the bracket here. This gives us y minus 1 is equal to 0.0175x minus 0.2625. When you simplify this, you have y is equal to 0.0175x minus 0.2625 plus 1. This gives us y is equal to 0.0175x plus 0.7375. The equation given to us in the question is y is equal to m plus nx. So here the constant comes first and then the term with x is second, and so let's arrange ours like that too. When we do that, this is going to be y is equal to, so the constant 0.7375 will be first, then plus the term with x will be second, 0.0175x. Now when you compare this to y is equal to m plus nx, you can see you have y here, equal to sign here, equal to sign here. So m is 0.7375. Then the n will be the coefficient of x here, which is 0.0175. Let's consider the last part of the question. It says that we should use the graph to estimate the height of the plant in 36 days. So what you do is that you come to the graph sheet and then you look for 36 on the number of days axis, which is the x-axis. So you look for 36 on the x-axis, you trace it to the line of best fit or the regression line, and then from there you trace it to the y-axis, which is the height axis, and then you read the value there. So 1.35. What this means is that the height of the plant in 36 days will be 1.35. So from the graph, the height of the plant in 36 days is 1.35. So as you can see, using the line of best fit or the regression line, we can predict the height of the plant in 36 days. We can predict how one variable will change as the other variable changes. This is another example of a question where we are required to draw the line of best fit by inspection. Sometimes you'll be required to draw the line of best fit through a specific point. Let's consider an example like that. The table shows the number of hours, y, spent by some workers, x, on similar jobs. So in the table, we have the number of workers here, and we have the number of hours here. The first part of the question says, draw a scatter diagram for the information. So as you can see here, we have not been given the scale, and so we have to choose our own scale. You choose an appropriate scale. B, find x mean, the mean of x, and y mean, the mean of y, and plot x mean, y mean on the diagram. C, draw the line of best fit to pass through x mean, y mean, and 4.6, 7.8. So here, You have been given two specific points the line of best fit should pass through. So you draw the line to pass through those 2 points. The next part of the question says, from the graph, find I, the equation of the line of best fit, and II, the number of hours a team of 2 workers would take to do a similar job. Let's start with the solution. The first part says we should draw the scatter diagram. So we are going to plot these points on our graph sheet. Remember, you have not been given a scale, so you have to choose an appropriate scale for your graph. This is my graph here. I'm using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 1 unit on the y-axis. Here are the points that we are going to plot. Let's start. The first one is 5, 10. So 5 on the x-axis, 10 on the y-axis. That will be here. The next one is 8, 7. 8 on the x-axis, 7 on the y-axis. That's here. The next one is 4, 10. 4 on the x-axis, 10 on the y-axis. That's here. The next one is 10, 1. 10 on the x-axis, 1 on the y-axis. That will be here. We have 6, 4. 6, 4 is here. We have 3, 7. 3, 7 is here. We have 5, 8. 5, 8 is here. We have 9, 3. 9, 3 is here. We have 10, 2. 10, 2 is here. And the last one is 7, 5. 7, 5 is here. This is the scatter diagram. Let's move on to the second part of the question. It says that we should find x mean, the mean of x, and y mean, the mean of y, and plot it on the diagram. So you find the mean of the x values, you find the mean of the y values, and then you plot it on the diagram. To get the mean of the x values, you add all of them together and divide it by their number. They are 10 in total. So you add 5 plus 8 plus 4 plus 10 plus 6 plus 3 plus 5 plus 9 plus 10 plus 7. And you divide that by 10. That gives us 6.7. To get the mean of y, we add all the y values together and divide it by 10, since they are 10 in number. So we add 10 plus 7 plus 10 plus 1 plus 4 plus 7 plus 8 plus 3 plus 2 plus 5. You divide that by 10 and that gives us 5.7. So you plot the point 6.7, 5.7 on the scatter diagram. Remember that the question said we should draw the line of best fit through x mean, y mean, and 4.6, 7.8. And so what we will do is that we will plot 6.7, 5.7 on the scatter diagram, and we also plot 4.6, 7.8 on the scatter diagram. Then we will draw the line through those 2 points, because the question said we should draw the line of best fit to pass through x mean, y mean, and 4.6, 7.8. So let's do that. We will plot 6.7, 5.7. That will be here. 6.7 on the x-axis, 5.7 on the y-axis. That will be here. The question also said we should plot 4.6, 7.8. So 4.6 on the x-axis, 7.8 on the y-axis. That will be here. Then we will draw the line through these 2 points. So this line will be our line of best fit, or the regression line. Let's consider the next part of the question. It says we should find the equation of the line. To get the equation of the line, we will need the gradient of the line and the coordinates of at least 1 point that falls on the line. Here we already have 2 points that fall on the line, so we can use the coordinates of those 2 points to find the gradient. From the graph, we know that 6.7, 5.7 and 4.6, 7.8 fall on the line. And so we can use this to find the gradient using the formula y2 minus y1 divided by x2 minus x1. I'm going to use 4.6, 7.8 as my x2, y2, and then I'll use 6.7, 5.7 as my x1, y1. So when we substitute that into this formula, we have 7.8 minus 5.7 divided by 4.6 minus 6.7. And this gives us -1. So the gradient of the line of best fit is -1. With this gradient and any one of these 2 points, I can use the formula y minus y1 is equal to m into bracket x minus x1 to get the equation of the line. I'm going to use 6.7, 5.7 as my x1, y1. So my x1 is going to be 6.7 and the y1 will be 5.7. The gradient m is -1. And so when you substitute it into the formula, you have y minus 5.7 is equal to -1 into bracket x minus 6.7. When you open the bracket here, you have y minus 5.7 is equal to -x plus 6.7. I'll move the -5.7 to the right hand side, and this becomes y is equal to -x plus 6.7 plus 5.7. This gives us y is equal to -x plus 12.4. When I move the terms on the right hand side to the left hand side, I'm going to have x plus y minus 12.4 is equal to 0. And this is the equation of the line. So the equation of the line of best fit is x plus y minus 12.4 is equal to 0. Let's consider the last part of the question. It says that from the graph, find the number of hours a team of 2 workers would take to do a similar job. So what you do is that you come to the graph, you go to the number of workers axis, which is the x-axis, then you look for 2. And then you trace it to the line of best fit or the regression line. Then where it meets the line, you trace it to the y-axis or the number of workers axis. Then you read the value there. On my graph sheet, when I read the value, I'm having 10.5. What it means is that it will take 2 workers 10.5 hours to complete the job. And so from the graph, a team of 2 workers will take 10.5 hours to do a similar job. And so using the regression line or the line of best fit, you have been able to predict how one variable will change as the other changes, how the number of hours will change as the number of workers changes. So far, we have solved about 3 questions on drawing the line of best fit by inspection. Next, we are going to learn how to draw the line of best fit by using the semi-averages method. Using the semi-averages method to draw the line of best fit. In order to use the semi-averages method to draw the line of best fit, you have to find the following points. The first one is x-mean, the mean of all the x values. And the second one is y-mean, the mean of all the y values. So you need x-mean, you need y-mean. After that, you need x1 mean. x1 mean is the mean of all the x values less than x mean. So you list all the x values less than x mean, and then you find their mean. That will give you your x1 mean. Then you have to find y1 mean. y1 mean is the mean of all the y values of corresponding x1 values. So the x1 values, their corresponding y values will give you your y1 values. You find the mean of those values. The next one is x2 mean. x2 mean is the mean of all the x values greater than x mean. So in the table, you list all the x values greater than x mean. That will give you your x2 values. You find the mean of those x2 values. Those x2 values, their corresponding y values will give you your y2 values. You find the mean of those y2 values. Don't worry if you don't understand how to find the x1, y1, x2, and y2. I'll use an example to explain how to find them to you. After finding all these values, on the scatter diagram, you plot x mean, y mean. Then you plot x1 mean, y1 mean. And then you plot x2 mean, y2 mean. You plot these 3 points on the scatter diagram. And then after that, you draw a straight line through x mean, y mean, and as close as possible to x1 mean, y1 mean, and x2 mean, y2 mean. In most examples, all these 3 points will be in a straight line. So your line of best fit will pass through these 3 points. But in a situation where they are not in a straight line, the line of best fit must pass through x mean, y mean, and it should be as close as possible to x1 mean, y1 mean, and x2 mean, y2 mean. Now let's apply this to solve some questions. You will learn how to find the x1 mean, y1 mean, x2 mean, and y2 mean. We already know how to find the x mean and y mean. Let's look at the first question. A. Construct a scatter diagram of the following pairs of values of x and y. So in the table, we have our x values here, we have our y values here. B. Using the semi-averages method. So you see here, the question is specific. Using the semi-averages method, draw the regression line of y on x. The regression line of y on x is the line of best fit. So using the semi-averages method, we are going to draw the line of best fit. And the last part of the question says, find the equation of the line and use it to predict the value of y when x is equal to 4.5. So after drawing the regression line of y on x, we will find the equation of the line, and then we will use the equation to predict the value of y when x is equal to 4.5. Let's start with the first part of the question, that is drawing the scatter diagram. Here we have not been given a scale, so we will choose an appropriate scale for our graph. I'm choosing 2 centimeters to 1 unit on both axes. So on the x-axis, we have 2 centimeters to 1 unit. On the y-axis, we have 2 centimeters to 1 unit. Here are the points. Let's plot them. The first one is 1, 2. So 1 on the x-axis, 2 on the y-axis. That will be here. We have 2, 1. 2 on the x-axis, 1 on the y-axis. That will be here. We have 3, 4. 3, 4 is here. We have 4, 7. 4, 7 is here. Then we have 5, 5. 5, 5 is here. We have 6, 6. 6, 6 is here. And then the last one is 8, 7. 8 here and 7. So 8, 7 will be here. This is our scatter diagram. Let's move on to the next part of the question. The next part of the question says that using the semi-averages method, we have to draw the regression line of y on x. That is the line of best fit. When using the semi-averages method, we need 3 main points. We need x mean, y mean. We need x1 mean, y1 mean, and x2 mean, y2 mean. We will start with x mean and y mean. X mean is the mean of all the x values. So we add all the x values together and we divide it by their number. There are 7 in total. 1, 2, 3, 4, 5, 6, 7. And so we add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8, and we divide that by 7. And that gives us 4.1. This is the x mean. We need y mean, the mean of y. We add all the y values together and we divide it by their number, which is 7. So we have 2 plus 1 plus 4 plus 7 plus 5 plus 6 plus 7. And then we divide that by 7, and that gives us 4.6. So x mean is 4.1 and y mean is 4.6. Next, we need x1 mean and y1 mean. To get x1 mean, we first need the x1 values. Remember, we learned that the x1 values are the x values less than the mean. So you see here in the table, the x values are 1, 2, 3, 4, 5, 6, 7. Now, when we found the mean of x, we had 4.1. The x1 values are the x values that are less than the mean, which is 4.1. So in the table, the x1 values will be the x values that are less than 4.1. From the table, we can see that the x values that are less than 4.1 are 1, 2, 3, and 4. These are the x values less than 4.1. Their corresponding y values will give you the y1 values. So you see, the y value of 1 here is 2. The y value of 2 here is 1. The y value of 3 here is 4. And the y value of 4 here is 7. These y values will be your y1 values. So our x1 values are 1, 2, 3, 4, as you can see in the table here. And their corresponding y values are 2, 1, 4, 7. So 2, 1, 4, 7 will be our y1 values. So this is our table for x1 values and y1 values. The remaining part of the table will be your x2 values and your y2 values, because we learned that your x2 values are the x values greater than x mean. Here x mean is 4.1. So the x values greater than 4.1 will be your x2 values. And from the table, we can see that the x values greater than 4.1 are 5, 6, and 8. So our x2 values are 5, 6, and 8. Their corresponding y values will give you your y2 values. The y value of 5 here is 5. The y value of 6 here is 6. The y value of 8 here is 7. So 5, 6, 7 will give us our y2 values. So our x2 values are 5, 6, and 8. Our y2 values are 5, 6, and 7. Now that we have the x1 values, y1 values, x2 values, and y2 values, we can find the x1 mean, y1 mean, x2 mean, and y2 mean. Let's do that. These are x1 values and y1 values. So our x1 mean will be equal to, we add all the x1 values together and we divide it by their number. They are 4. So 1 plus 2 plus 3 plus 4 divided by 4. And that gives us 2.5. The mean of y, that will be our y1 mean, will be equal to, we add all the y1 values together and we divide it by their number. So 2 plus 1 plus 4 plus 7 divided by 4. And that gives us 3.5. So x1 mean is 2.5, y1 mean is 3.5. This is the table for x2, y2. x2 mean, or the mean of x2, will be, we add all the x2 values together, we divide it by their number. They are 3. So 5 plus 6 plus 8 divided by 3, that gives us 6.3. The mean of y2, we add all the y2 values together, we divide it by their number. 5 plus 6 plus 7 divided by 3, and that gives us 6. So now we have found x mean, y mean, x1 mean, y1 mean, x2 mean, y2 mean. And so we are going to plot the points x mean, y mean, x1 mean, y1 mean, and x2 mean, y2 mean on the scatter diagram. Then we will draw the regression line of y on x, or the line of best fit through it. Our x mean, y mean is 4.1, 4.6. x1 mean, y1 mean is 2.5, 3.5. And x2 mean, y2 mean is 6.3, 6. Let's plot these points on the scatter diagram. This is our scatter diagram. The first point, which is the x mean, y mean, is 4.1, 4.6. So 4.1 on the x-axis, 4.6 on the y-axis. That will be here. That is 4.1, 4.6. The next one is 2.5, 3.5. So 2.5 on the x-axis, 3.5 on the y-axis. That will be here. 2.5, 3.5. That is x1 mean, y1 mean. And the last one is 6.3 and 6. So 6.3 on the x-axis, 6 on the y-axis. That will be here. That gives us x2 mean, y2 mean. After this, we will draw the line of best fit through these 3 points. So you draw the line of best fit through them. As you can see, all the 3 points fall on the line. This gives us the regression line of y on x, or the line of best fit. This is how to draw the line of best fit using the semi-averages method. Let's consider the next part of the question. It says that find the equation of the line and use it to predict the value of y when x is equal to 4.5. To find the equation of the line, we will need the gradient of the line and the coordinates of at least one point that fall on the line. On our graph, we can see that 3 points fall on the line. We have one here, and one here. We can pick any 2 of them to find the gradient of the line, and then with the gradient and any one of these coordinates, we can find the equation. Here, I'm going to pick the point 2.5, 3.5, and 4.1, 4.6 to find the gradient. So from the graph, the points 4.1, 4.6, 2.5, 3.5 fall on the line. We can use these 2 points, the coordinates of these 2 points, to find the gradient, because we know that the gradient of the line will be given by y2 minus y1 divided by x2 minus x1. I'm going to use 4.1, 4.6 as my x1, y1, and 2.5, 3.5 as my x2, y2. When I do that, I'll have 3.5 minus 4.6 divided by 2.5 minus 4.1. And this gives us 0.6875. So the gradient of the line is 0.6875. With this gradient and any one of these 2 points, we can find the equation of the line using the formula y minus y1 is equal to m into bracket x minus x1. The gradient is 0.6875, so m is 0.6875. I'll use the point 2.5, 3.5. So 2.5 is going to be x1 and 3.5 is going to be y1. When we substitute that information here, we have y minus 3.5 is equal to 0.6875 into bracket x minus 2.5. Let's do some simplification here. When we open the bracket, we have y minus 3.5 is equal to 0.6875x minus 0.6875 times 2.1 gives us 1.71875. I'll send negative 3.5 to the right hand side. When I do that, I'll have y is equal to 0.6875x minus 1.71875 plus 3.5. And this gives us y is equal to 0.6875x plus 1.78125. This is the equation of the line of best fit, or the equation of the regression line of y on x. The question says that we should use the equation of the line to predict the value of y when x is equal to 4.5. When x is equal to 4.5, we have the equation of the line y is equal to 0.6875x plus 1.78125. So we will replace x here with 4.5. When we do that, we will have y is equal to 0.6875 times 4.5 plus 1.78125. And this gives us 4.875. So using the equation of the line of best fit, when x is equal to 4.5, y is equal to 4.875. Let's consider another question on drawing the line of best fit, or the regression line of y on x, using the semi-averages method. The table shows the marks out of 10 in a class test in English and mathematics of a sample of 10 students selected at random from a class. In the table, we have the English scores here given to us as x, and the mathematics course here given to us as y. The first part of the question says that draw a scatter diagram of the data. Then B, if x mean is the mean of x and y mean is the mean of y, find I. The mean values of x1 and y1 of x and y respectively, for which x is less than the mean of x. II. The mean values of x2 and y2 of x and y respectively, for which x is greater than the mean of x. And then CI. Plot the points x mean, y mean, x1 mean, y1 mean, and x2 mean, y2 mean on your scatter diagram. III. Find the equation of the line of best fit and use it to predict the possible mathematics mark of a student who scored 2 in English. So here you can clearly see we are going to use the semi-averages method, because the question says you should plot x mean, y mean, x1 mean, y1 mean, x2 mean, and y2 mean. So you find all these 3 points and then you plot it on the scatter diagram. Then you draw the line of best fit through it. Let's begin with the first part of the question, which is we should draw a scatter diagram for the data. Here we have not been given a scale, so you have to choose an appropriate scale. The English scores will be on the x-axis and the mathematics scores will be on the y-axis. I'm using a scale of 2 centimeters to 1 unit on both axes. Here are the points we are going to plot. Let's start. The first one is 3, 4. We have 3 on the x-axis, 4 on the y-axis. That will be here. We have 3, 6. 3, 6 will be here. We have 4, 5. 4, 5 is here. We have 5, 4. 5, 4 is here. We have 6, 6. 6, 6 is here. Then 7, 8. 7, 8 is here. 7, 9. 7, 9 is here. 9, 10. 9, 10 is here. And the last one is 6, 9. 6, 9 is here. This is our scatter diagram. Let's move on to the next part of the question. For the next part of the question, we are going to find x mean, y mean, x1 mean, y1 mean, x2 mean, y2 mean. So let's begin with x mean and y mean. X mean is the mean of all the x values. The x values are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we add all of them together and then we divide it by 10. So we have 3 plus 3 plus 4 plus 5 plus 6 plus 7 plus 7 plus 8 plus 9 plus 6. And then you divide that by 10 and that gives us 5.8. So x mean is 5.8. We find y mean. We add all the y values together and we divide it by 10 since they are 10 in number. So you have 4 plus 6 plus 5 plus 4 plus 6 plus 8 plus 9 plus 7 plus 10 plus 9 divided by 10, and that gives us 6.8. So x mean is 5.8 and y mean is 6.8. Now we need to find x1 mean, y1 mean, x2 mean, and y2 mean. Let's begin with x1 mean and y1 mean. Before that, let's find the x1 values and the y1 values. Remember, the x1 values are all the x values less than the mean of x. Here, the mean of x is 5.8. So the x1 values are the x values less than 5.8. From the table, the x values less than 5.8 are 3, 3, 4, 5. And so these are the x1 values. Their corresponding y values gives us the y1 values. The y value of 3 here is 4. The y value of 3 here is 6. The y value of 4 here is 5. And the y value of 5 here is 4. So 4, 6, 5, 4 are the y1 values. So our x1, y1 table will be 3, 3, 4, 5, 4, 6, 5, 4. The remaining part of the table will be your x2, y2 values, because the x2 values are the x values greater than the mean of x. The mean of x is 5.8. So the x values greater than 5.8. And from the table, we can see that those values are 6, 7, 7, 8, 9, 6. These are the x values greater than the mean of x, which is 5.8. And so these are our x2 values. Their corresponding y values are the y2 values. The y value of 6 here is 6. The y value of 7 here is 8. The y value of 7 here is 9. The y value of 8 is 7. The y value of 9 is 10. And the y value of 6 here is 9. And so the y2 values are 6, 8, 9, 7, 10, 9. So our x2, y2 values are 6, 7, 7, 8, 9, 6. That's the x2 values. And the y2 values are 6, 8, 9, 7, 10, 9. Now that we have the x1 values, y1 values, x2 values, y2 values, we can find x1 mean, y1 mean, x2 mean, and y2 mean. These are our x1 values, y1 values. The mean of x1, that is x1 mean, will be, you add all the x1 values together and we divide it by their number. There are 4 in total, so we have 3 plus 3 plus 4 plus 5 divided by 4. And that gives us 3.75. The mean of y1, that's y1 mean, will be, we add all the y1 values together, we divide it by their number. So 4 plus 6 plus 5 plus 4 divided by 4. And that gives us 4.75. So x1 mean, y1 mean is 3.75, 4.75. This is our table for x2, y2. To get mean of x2, that is x2 mean, we add all the x2 values together, we divide it by their number. There are 6 in total, so we have 6 plus 7 plus 7 plus 8 plus 9 plus 6 divided by 6, and that gives us 7.2. Next, we find the mean of y2, that's y2 mean. We add all the y2 values together and we divide it by their number, which is 6. So we have 6 plus 8 plus 9 plus 7 plus 10 plus 9. You divide that by 6 and that gives us 8.2. We are going to plot x mean, y mean, x1 mean, y1 mean, x2 mean, y2 mean on the scatter diagram. Then we will draw the line of best fit through them. X mean, y mean is 5.8, 6.8. X1 mean, y1 mean is 3.75, 4.75. And x2 mean, y2 mean is 7.2, 8.2. Let's plot these points on the scatter diagram. The first one, 5.8, 6.8. So 5.8 on the x-axis, 6.8 on the y-axis. That will be here. 5.8, 6.8. The next one is 3.75, 4.75. So 3.75 on the x-axis, 4.75 on the y-axis. That will be here. 3.75, 4.75. And the third one is 7.2, 8.2. So 7.2 on the x-axis, 8.2 on the y-axis. That will be here. 7.2, 8.2. As you can see, all 3 of them are in a straight line. So you draw the line through them. This line is the line of best fit or the regression line of y on x. Let's consider the next part of the question. It says that find the equation of the line of best fit and use it to predict the possible mark of a student who scored 2 in English. On our scatter diagram, we can see that the line of best fit passes through this point with coordinate 3, 4. It also passes through this point with coordinate 3.75, 4.75. It passes through this one as well with coordinates 4, 5. It passes through this with coordinates 5.8, 6.8. And it passes through this one with coordinates 7.2, 8.2. We can use any two of these points to find the gradient of the line. And then when we have the gradient, we can use the gradient and any one of these points to find the equation. Here I'm going to use the points 5.8, 6.8 and 7.2, 8.2 to find the gradient of the line. The gradient is given by the formula y2 minus y1 divided by x2 minus x1. I'll use 5.8, 6.8 as my x1, y1 and 7.2, 8.2 as my x2, y2. When I substitute that here, I'll have 8.2 minus 6.8 divided by 7.2 minus 5.8. And this gives us 1. So it means the gradient of the line is 1. Now, using this gradient and any one of these 2 points, we can find the equation of the line by using the formula y minus y1 is equal to m into bracket x minus x1. M is the gradient of the line. We have found out to be 1. So m is equal to 1. We need the coordinate of 1 point that falls on the line. Here I'm going to use 5.8, 6.8. So 5.8 will be my x1 and 6.8 will be my y1. When we substitute that here, we have y minus 6.8 is equal to 1 into bracket x minus 5.8. This gives us y minus 6.8 is equal to x minus 5.8. I'll move negative 6.8 to the right hand side. This gives us y is equal to x minus 5.8 plus 6.8. And this gives us y is equal to x plus 1. So the equation of the line of best fit is y is equal to x plus 1. Now the question says that we should use the equation to predict the possible mark of a student who scored 2 in English. Remember, from the table, the English values were given to us as our x values. So basically, the question is telling us that we should use the equation to find y when x is 2. From the equation of the line, y is equal to x plus 1. So when x is equal to 2, y will be equal to 2 plus 1. And 2 plus 1 is 3. So this means that if a student scored 2 in English, then their possible score in mathematics is 3. We have solved 2 examples on drawing the line of best fit or the regression line using the semi-averages method. Now, let's learn how to use the least squares method to draw the line of best fit. Using the least squares method to draw the line of best fit. The least square method gives the equation of the line of best fit. So unlike the previous methods where we draw the scatter diagram, then we draw the line of best fit on the scatter diagram, and then we find the equation of the line of best fit, with the least squares method, we are going to use the data points given to us, the data given to us in the question. We will use it to find the equation of the line of best fit. Then we will draw the graph of that line on the scatter diagram. So the least square method will give us the equation of the line of best fit. Then we draw the graph of the equation on the scatter diagram. In the lesson on straight lines, we learned how to draw the graph of a straight line when you have the equation of the line. We are going to apply that knowledge here. We have learned that the equation of a straight line is given by the formula y is equal to ms plus c. With the least squares method, we will be able to find the value of m and c using the data points given to us. The value of m is given by n sigma xy minus sigma x times sigma y divided by n sigma x squared minus sigma x all squared, where n is the number of data points and the x and y here are the x and y values given to us in the table. So this gives us m. C is equal to sigma y divided by n minus m sigma x divided by n. So the value of m we will get here, we will substitute it here to get the value of C. The x and y values are the x and y values given to us in the table. N is the number of data points. So using the least squares method, we can use this formula to find the value of m and c. When we find the value of m and c, we will substitute them into this equation, y is equal to ms plus c, and that will give us the equation of the line of best fit. Then we will draw the graph of that equation on the scatter diagram to get the line of best fit. So this is how to find the line of best fit using the least square method. From the data points given to us, we can get sigma xy, sigma x, sigma y, and sigma x squared. Then we will substitute that information here to get the value of m. And then after we get the value of m, c will be given by sigma y divided by n minus m times sigma x divided by n. Let's apply this to solve a question. It will help you to understand it better. Here is the first question. The distribution of marks scored in mathematics and English by some students is shown in the table below. So we have the mathematics score here and the English scores here. The question says the mathematics scores are the X scores and the English scores are the Y scores. For the first part of the question, we are being asked to draw a scatter diagram of the distribution. B. Using the least square method, draw the line of best fit. You see here, the question says we should use the least square method. So we are going to use the least square method. And C. From the graph, find the mark obtained in English by a student who obtained 8 in mathematics. Let's start with the first part of the question. We are going to draw a scatter diagram for the distribution. You see here, the question did not give us a scale, so you have to choose an appropriate scale for your graph. The mathematics scores will be on the x-axis and the English scores will be on the y-axis. Here I'm going to choose a scale of 2 centimeters to 1 unit on both axes. Here are the points we are going to plot. Let's start with the first one. 1, 3. So 1 on the x-axis and 3 on the y-axis. That will be here. The next one is 2, 1. 2 on the x-axis, 1 on the y-axis. That's here. We have 3, 4. 3 on the x-axis, 4 on the y-axis. That will be here. We have 4, 2. 4 on the x-axis, 2 on the y-axis. We have 5, 6. 5 on the x-axis, 6 on the y-axis. And then we have 6, 7. 6 on the x-axis, 7 on the y-axis. That's here. And we have 7, 5. 7 on the x-axis, 5 on the y-axis. That's here. So this is our scatter diagram. Let's look at the next part of the question. It says that using the least square method, draw the line of best fit. As we have learned, with the least squares method, we can find the equation of the line of best fit. So that's what we are going to do. We will begin by drawing a table with 4 columns, as you see here. In the first column, we will have the mathematics scores. That will be our x values. In the second column, we have the English scores. That will be our y values. In the third column, we will have x squared, where we will square the x values. And in the fourth column, we will have xy, where we will multiply the x and y values. This is because, as we have learned, the equation of the line of best fit, which is a straight line, will be given by y is equal to mx plus c. And m is equal to n sigma xy minus sigma x sigma y divided by n sigma x squared minus sigma x squared. So we need sigma xy. That is why we have a column for xy. And we also need sigma x. So we have a column for x here. We need sigma y. We have a column for y here. And we need sigma x squared. So we have a column for x squared here. Remember that c will be equal to sigma y divided by n minus m times sigma x divided by n. And n is the number of data points. So here we have 1, 2, 3, 4, 5, 6, 7. So n will be equal to 7 because we have 7 data points. Now let's find the x square values and then the xy values. To get the x squared values, we are going to square the x values. The x values are the mathematics course. So we take the first one, we square it, the next one we square it, and so on. The first one is 1. 1 squared gives us 1. The next one is 2. 2 squared gives us 4. 3 squared gives us 9. 4 squared gives us 16. 5 squared is 25. 6 squared is 36. And 7 squared is 49. Next, we need x, y. So we will multiply the x and y values. 1 times 3 gives us 3. 2 times 1 gives us 2. 3 times 4 gives us 12. 4 times 2 is 8. 5 times 6 is 30. 6 times 7 is 42. And 7 times 5 is 35. Now we will need sigma x, so we add all the x values, that gives us 28. We will need sigma y, so we add all the y values, that gives us 28. We will need sigma x squared, so we add all the x squared values, that gives us 140. And we will need sigma xy, so we add all the xy values, and that gives us 132. Now we will substitute this information into the formula to get the value of m. Remember, n is the number of data points, and we counted them and we had 7, so n is equal to 7. So let's substitute all of that here. On the numerator, we have n sigma xy, so n times sigma xy. N is 7, sigma xy from the table is 132, so 7 times 132 minus, we have sigma x times sigma y. Sigma x is 28, sigma y is 28. So that will be minus 28 times 28 divided by, n is 7. From the table, sigma x squared is 140. So we have 7 times 140 minus, we have sigma x squared. So we are going to square the sigma x. From the table, sigma x is 28. So sigma x squared will be 28 squared. And this gives us 5 divided by 7. So m, which will be the gradient of the line, is 5 divided by 7. Now we need c. C will be equal to sigma y divided by n minus m sigma x divided by n. From the table, sigma y is 28. We divided by n, which is 7. Then minus m, we have found out to be 5 divided by 7. So we have 5 divided by 7 times sigma x, which is 28, as you can see from the table, divided by n, which is 7. And this gives us 8 divided by 7. So for the equation of the straight line, m, which is the gradient, is 5 divided by 7, and c, which is the y-intercept, is 8 divided by 7. We know that the equation of the line of best fit is given by y is equal to mx plus c. And we have found m to be 5 divided by 7 and c to be 8 divided by 7. So when you substitute it here, the equation becomes y is equal to 5 divided by 7 x plus 8 divided by 7. This gives us the equation of the line of best fit. Now that we have the equation of the line, we are going to draw the graph of this equation on the scatter diagram. In the lesson on straight lines, we learned that to draw the graph of a linear equation on a graph sheet, you will need at least 2 points that fall on the line. And you get those 2 points by assuming an x coordinate, you substitute it into the equation, you get a y coordinate. Then you assume another x coordinate, you substitute into the equation, you get a y coordinate. With those 2 points, you plot it on the graph and then you join them with your straight line, and that gives you the graph of the line. Here, in choosing the x coordinate that you are going to substitute into the equation, you have to make sure that the x coordinate is on the graph. The x coordinate that you are choosing, it is such that you can actually plot it on the graph. And the resulting y coordinate that you obtain is also such that you can plot it. So don't choose an x coordinate that can't be found on the graph depending on the scale that you choose. So always look at your scale and choose an x-coordinate that you can find on the graph, and it should be such that when you substitute it into the equation, the resulting y-coordinate that you get should also be found on the graph so that you can actually plot it. Okay, so here I'm going to choose x is equal to 2. Then I will substitute it into the equation to get the corresponding y value. The equation is y is equal to 5 divided by 7x plus 8 divided by 7. So when x is equal to 2, y will be equal to 5 divided by 7 times 2 plus 8 divided by 7. And this gives us 2.6. Then I will need another point. So I'll choose another x coordinate and then substitute it into the equation again to get the corresponding y. I'll choose when x is equal to 5. When x is equal to 5, y will be equal to 5 divided by 7 times 5 plus 8 divided by 7. And this gives us 4.7. So I now have 2 points that fall on the line. When x is 2, y is 2.6. And when x is 5, y is 4.7. When I plot these 2 points on the scatter diagram and join them with a straight line, I will get the line of best fit. Once again, in choosing these 2 points that you need to draw the graph of the line, make sure that the points you are choosing can be plotted on the graph based on the scale that you have chosen. On my graph sheet, I chose a scale of 2 centimeters to 1 unit on both axes. So as you can see, x is equal to 2 can be found on the graph, y is equal to 2.6 can also be found on the graph. In the same way, x is equal to 5 can be found on the graph, and y is equal to 4.7 can be found on the graph. Don't choose an x-coordinate that you can't even plot on the graph. And the x-coordinate you choose should also be such that when you substitute it into the equation, the resulting y-coordinate that you obtain, you can find it on the graph and actually plot it. Okay, so we are going to plot these 2 points on the graph sheet. Here is my scatter diagram. The points I'm going to plot are 2, 2.6, and 5, 4.7. So the first one is 2, 2.6. So 2 on the x-axis, 2.6 on the y-axis. That will be here. The next one is 5, 4.7. So 5 on the x-axis, 4.7 on the y-axis, and that will be here. Now I'll join these 2 points with a straight line, and this gives me the line of best fit. So you see, with the least square method, it gives you the equation of the line, then you draw the graph of the line on the scatter diagram to get the line of best fit. Let's look at the next part of the question. The next part of the question says that from the graph, find the mark obtained in English by a student who obtained 8 in mathematics. So we are going to use the graph to find the mark obtained in English by a student who obtained 8 in mathematics. So what we will do is that the student obtained 8 in mathematics. So we will come to the mathematics axis, which is the x-axis. Then we will look for 8. And then we will trace it to meet the line. Then from there, we will trace it to meet the English axis, which is the y-axis. Then we will read the value there. Here, when I read the value, I'm getting 6.7 from my graph. What this means is that from the graph, if a student obtained 8 in mathematics, then the student scored 6.7 in English. Let's consider another question. The following table shows the marks obtained by some students in the 2 papers of a subject. We have paper 1 and paper 2. Paper 1 will give us the x values and paper 2 will give us the y values. The first part of the question, A, it says plot a scatter diagram to represent the information. B, using the least squares method, draw the line of best fit. C, from your graph, determine I, the value of y when x is 25, and II, the value of x when y is 30. Let's start with the first part, plotting the scatter diagram. Here, I'm going to choose a scale of 2 centimeters to 10 units on both axes. So on the x-axis, I'll have 2 centimeters to 10 units. On the y-axis, I'll have 2 centimeters to 10 units. Let's plot the points. The first one is 5141. 5141 will be here. The next one is 4538. We'll have that here. The next one is 2311. 2311 will be here. We have 4728. 4728 will be here. We have 1812. 1812 will be here. Then we have 3114. 3114 will be here. We have 2714. 2714 is here. We have 3017. 3017 will be here. We have 2115. 2115 is here. And the last one is 2317. 2317 is here. So this is our scatter diagram. Let's move on to the next part of the question. It says that using the least squares method, draw the line of best fit. As we have learned, the least squares method gives us the equation of the line of best fit. So let's find that. We will draw a table with 4 columns. In the first column, we will have the x values, which should be for paper 1. In the second column, you have the y values, which should be for paper 2. In the third column, you have x squared. And in the fourth column, you have xy. Let's find the x squared and xy values. To get the x squared values, you square the x values here. So the first one will be 51 squared, and that will be 2601. The next one is 41 squared, that is 2025. The next one is 23 squared, that is 529. We have 47 squared, that is 2209. We have 18 squared, that is 324. 31 squared is 961. 27 squared is 729. 30 squared is 900. 21 squared is 441. And 23 squared is 529. Now we need xy, so you multiply the x and y values. 51 times 41 gives 2091. 45 times 38 gives 1710. 21 times 11 is 253. 47 times 28 is 1316. 18 times 12 is 216. 31 times 14 is 434. 27 times 14 is 378. 30 times 17 is 510. 21 times 15 is 315. And 23 times 17 is 391. We need the sum of all these values. So you find sigma x, that gives us 316. We find sigma y, that gives us 207. We find sigma x squared, that gives us 11248. And we find sigma xy, and that gives us 7614. Remember that the equation of the line of best fit is given by y is equal to mx plus c, where m is the gradient of the line and c is the y-intercept. M is given by the formula n sigma xy minus sigma x sigma y divided by n sigma x squared minus sigma x squared. N is the number of data points. So let's count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 data points, so n is 10. We have the value of sigma xy, sigma y, sigma x squared. So we will substitute everything here. This gives us n, which is 10, times sigma xy from the table. Sigma xy is 7614. So 10 times 7614. Then minus, we have sigma x times sigma y. Sigma x is 316. Sigma y is 207. So we have 316 times 207. And this will be divided by n sigma x squared. N is 10 times sigma x squared is 11248. So we have 10 times 11248 minus, we have sigma x squared, and sigma x is 316. So sigma x squared will be 316 squared. And this gives us 447 divided by 526. Now we can find C. C is given by the formula sigma y divided by n minus m, which we have just found, times sigma x divided by n. Remember, n is 10 because the data points are 10. We have the value of sigma y and sigma x. So we substitute everything here. This will be equal to sigma y, which is 207 divided by n, which is 10, minus m, which is 447 divided by 526, times sigma x is 316. So 316 divided by n, which is 10. And this gives us negative 3237 divided by 526. So we have the value of m and we have the value of c. And so we can find the equation of the line. We know that the equation of the line is given by the formula y is equal to mx plus c. M is 447 divided by 526, and c is negative 3237 divided by 526. So when you substitute it into y is equal to mx plus c, y will be equal to 447 divided by 526x, then minus 3237 divided by 526. With this, we can draw the graph of the line. We will need 2 points that fall on the line. We will assume an x coordinate, we will substitute it into the equation, we will get a y coordinate. We assume another x coordinate, we will substitute it into the equation, we will get a y coordinate. Then we will plot those 2 points on the scatter diagram and join them with a straight line to get our line of best fit. But just as I explained in the previous example, make sure that the x coordinate you are picking can be plotted on the graph, and the y coordinate you will get after you have substituted it into the equation can also be found on the graph so that you plot them. Here I'm going to choose x is equal to 40. So you always look at your scale and you choose a number that is between the highest value of x and the lowest value of x. Usually when you pick any of those numbers, you can easily plot it. When I choose x equal to 40, to get y, I will substitute it into the equation here. So y will be equal to 447 divided by 526 times 40 minus 3237 divided by 526. And this gives us 27.8. I'll choose another value for x because I will need 2 points that fall on the line. I'm choosing x equal to 60. When x equal to 60, y will be equal to 447 divided by 526 times 60 minus 3237 divided by 526. And this gives us 44.8. So now I have 2 points that fall on the line. When x is 40, y is 27.8. And when x is 60, y is 44.8. We will plot these 2 points on the scatter diagram and join them with a straight line to get the line of best fit. As you can see here, the first one, the x coordinate is 40, the y coordinate is 27.8. So as you can see, we have 40 here, 27.8 will be somewhere between 20 and 30. So you see, you can actually plot them on the graph. Okay. And then the second one too, you have 60 and 44.8. So 60 is here, 44.8 will be somewhere between 40 and 50. So you can plot them. So always make sure that the x coordinate you are choosing can be found on the graph, and the resultant y coordinate can also be found on the graph. It's always easy to look at the smallest value of x you have on the graph, look at the biggest value of x you have on the graph, and choose a value that is somewhere in between. So as you can see here, the smallest value of x I have here is 0. The biggest value is 90. So I chose 40 and 60. Just choose a number between them. When you do that, it's likely that your resultant y value will also be on the graph. Let's plot these points. The first one is 40, 27.8. So 40 on the x-axis, 27.8 on the y-axis. That will be here. The next one is 60, 44.8. 60 on the x-axis, 44.8 on the y-axis. That will be here. You join them with a straight line to get the line of best fit. Let's look at the last part of the question. It says that from your graph, determine I, the value of y when x is 25, and II, the value of x when y is 30. For the first part, it says we should find the value of y when x is 25. So you look for 25 on the x-axis, then we will trace it to meet the line, and from where it meets the line, we will trace it to meet the y-axis. Then we will read the value there. When I read the value on my graph, I'm getting 15. So it means that from the graph, when x is 25, y is 15. For the second part, it says we should find the value of x when y is 30. So I'll look for 30 on the y-axis, which is here. I'll trace it to meet the line of best fit, and then from there, I'll trace it to meet the x-axis and read the value there. When I do that, the value I'm getting on my graph is 43. It means that from the graph, when y is 30, x is 43. This is the end of the lesson on correlation and regression. Thank you for watching this video. Subscribe to this channel for more lessons. See you in the next one. Bye-bye.